Thank you, Rob, for the introduction to the session, and to Garth for preparing the remarks, even though we weren't able to hear them, unfortunately. So if you're able to hear Garth's remarks, a lot of what he was talking about was sort of this idea of seizing opportunities and building better, more sustainable communities. And that's really what today's panel is all about. More sustainable infrastructure, more efficient use of local resources, and the opportunities that exist for communities to play a leading role in building a local bioeconomy, which in turn will generate revenue for municipalities, create jobs, stimulate the local economy, and lead to more resilient, self-sufficient communities. I'm Jean Blair. I've been researching and consulting in the forest bioeconomy space for 10 years now. As you can see on the screen, I am a postdoctoral fellow at Queen's University, but I also work in various capacities with all of our panelists today, as well as the Circular Bioeconomy Group at the Canadian Forest Service. So I've worked with Sebna Madrali. Sorry, I'm just trying to go to the next slide there. Great. I've worked with Sebna Madrali, research engineer at CanMed Energy since 2004, on the creation and maintenance of the Canadian Bioheat database, which you'll hear a bit more about today, particularly the community projects. Throughout my PhD, Jamie Stephen, managing director at Torchlight Bioresources, contracted me to work on several bioenergy and biomass supply chain related projects, which increasingly have been focused on opportunities at the municipal level. And in fact, we recently completed a project looking at opportunities for community bioenergy in the central Kootenay region with our third panelist, Dominic Roser. Dominic is a professor at the University of British Columbia, but prior to that, he spent several years with the Finnish Forest Resource Institute, as well as FP Innovations. Anyway, we have a great panel lined up for you today, and I want to make sure that we've got lots of time for question and answers at the end. So without further ado, we'll hand the screen over to Dominic to share his knowledge on biomass supply from a community perspective. And just a quick reminder to use the Q&A box, not the chat box, for any questions you'd like answered. And feel free to upvote them to move them to the top of the list as well. And I'll be monitoring the Q&A to moderate the discussion after we hear from our three panelists. So Dominic, over to you.
Yes, thank you very much, Jean, for the introduction. Good morning, everyone. To our colleagues in Finland, hyvää iltaa, and god kväll to our colleagues from Sweden. So we have a very international audience this morning, evening, wherever you are. And I'm very glad to talk to you today about my perspectives on community bioenergy. And so I've been in Canada now for almost 8 years, actually a little bit more than 8 years. And you know, when I came to Canada in 2012, I really was hired to talk about community bioenergy. And I think we've come a long way since then, and in some ways we are still at the same place. So I'm very glad to see that there is focus again in BC, and I think across Canada, on community bioenergy opportunities. And I think, based on my experience in Finland and in Sweden, working across Europe, it's very great to see this focus again on district heating and combined heat and power systems, which I think is the entry and into the market in building confidence to be ready that when we have more advanced opportunities coming up in terms of bioproducts, biofuels, that we collectively are ready to participate in those activities. And I think this opportunity right now to build that solid foundation is a very great way to start. So one of the projects that I have been involved in for quite some time, this was even when I started working at FP Innovations, was combined heat and power. I think it's very great to see that we are seeing more and more district heating opportunities for heat only, using wood chips, I think, across Canada. And I would say that we have built that solid foundation. And now these projects are actually something normal. They are not that special anymore, which is completely different from the situation in 2012. So we have built that solid base of contractors that know what they're doing, supply chains that know what they're doing, and we'll hear about that in a later from a panelist later on. And so I think that's a really key development for moving forward. And I think that's also how it happened in Nordic countries. You kind of reach that point where a technology becomes integrated into existing energy systems, and then it starts taking off from there. On the combined heat and power side, I think we still have a long ways to go. We have lots of communities that are not connected to any infrastructure, and that have to fly in diesel. They have to ship in diesel and generate electricity from through diesel power generation. And I think the opportunity moving forward is really building on this, trying to establish systems that use local forest resources to power these communities. And so we've been working with FP Innovations, with NRC, colleagues from CanMet, that have been trying to establish this combined heat and power technology in British Columbia. I think we have a system working already in the north, in Quadacha. And now we have another system. The German system is working in Quadacha. We have a Finnish system that we've tested here at NRC in Vancouver. You can see here in the few pictures, we've developed wood chip storage systems that dry the chips down to the 11% moisture content. And that kind of tests the entire supply chain and production. And now that system is planning, or is on its way to the Coscas community near Williams Lake. And it's very great to see that these technologies are evolving. I think the holistic approach that I put on the slide here is really a key, that we start to work on all the different things that can go wrong and solve these issues before these systems go into the community, that we train. As in the middle here, you have a picture from a training of Coscas members at FP Innovations, so that they know once the system comes to their community, that they know how to operate it moving forward. But when it comes to community bioenergy, I think we cannot talk about this without talking that we need to improve our forest management. And I think this is something that's true across Canada. And I think this community bioenergy actually, that the community bioeconomy provides the opportunity to do that. And again, I think this is something where we can learn and adapt from the experiences in Nordic countries and in other European countries, where the solid forest sector has really helped to promote these kind of bioeconomy opportunities based on local resources. And I'm getting philosophic this morning, but there's a Finnish saying that forests are not inherited from our parents, they are borrowed from our children. And I think that's the attitude we need to develop here as well. We don't have private forest ownership as many countries in Europe, but I think this is the thinking we all need to start to adopt in order to be successful moving forward, and also to ensure that we're doing the right thing when we are managing our forests. And I think there is plenty of opportunities that we're currently not tapping into. Commercial thinnings is one of those opportunities, using that material that comes out of commercial thinnings for our industrial processes, but also to power the bioeconomy in bioheat projects, combined heat and power projects that I just talked about. I think they can be used for pellets, for biofuels. I think this is a very large untapped resource that not only provides additional fiber sources, but also helps us reduce fire risks, to increase forest resiliency to for example, the mountain pine beetle attacks that we have seen. We need to increase our value and really start getting away in BC, especially from thinking only about volume, but value, quality of logs at the end of the rotation. And then, of course, and I'll talk about this in my next slide, slash burning, which is a very big topic. And I think if we do a better job at managing our forest, we can also manage to produce less waste along the entire managing process. And there's lots of capacity being built in BC right now. We're working with government. We just got a very large research project approved that is dealing with silviculture. The community of Quesnel here, shout out to them. They're working hard through their forestry initiatives program to get that momentum going. And I think all of these opportunities contribute to community sustainability. As I said, harvest residues are still a big challenge for us moving forward. And as I said, our forest management needs to improve in order to address these challenges. Another big project we're currently involved in is wildfire carbon and bioeconomy that's funded through PICS. And this is really aiming to use those opportunities around wildfire management, salvage logging operation, fuel treatment, and instead of burning this material, trying to find economic uses for it moving forward. Great project. It's an international collaboration with the US Forest Service, where we're getting information from them. And it's a really great effort to create these kind of opportunities. And the picture here is a plant in Sweden that is producing modular homes made out of wood. And you can see here in a factory that is, looks like a car factory. That's, I think, the vision that we need to go to, and that is the opportunity in the bioeconomy. And we cannot talk enough about this without having this proper supply chains to deal with this material. And I really want to stress this. We need to have, and I think Sepnem will be talking about this as well, we need to have proper supply chains that produce the kind of quality of chips that we need moving forward. But we also need to train the next generation of practitioners. And this is really targeted at a new way of doing forest management. We can see here in this graph that our productivity in forest operations has decreased since the 2000s due to all of the additional demands on our supply chains and foresters. And that this is something we need to change, and we can change moving forward with advanced technologies. And also operator training. This is, again, something that we are working on with Quesnel in training the next generation of forest machine operators so that they can make good decisions and know how to operate these expensive machines that we are bringing in. But I want to end with the built environment. And this is something that is right in front of us. And so I have a PhD, working with a PhD student that's finished his thesis, is now a postdoc, that looked at mitigating effect of different bioeconomy opportunities. And we can actually see that the mitigating effect of bioenergy is much less than, for example, construction. So what he's done, Sheng, is build different scenarios, looking at the base case scenario as is today and looking, okay, what if we use all the wood that we're producing in BC for construction? What if you use it for biofuel? What if we use the black liquor in different scenarios? And I'm happy to talk to you about this in more detail. But really what I want to stress here, that a scenario that is here, number one, where everything is going into wood buildings, that would be the best, but it's probably unrealistic in BC. A scenario where we're exporting less and not getting the substitution effect is also not a solution. So moving forward, a construction-dominated and biofuel subordinated scenario, which here is number 3, is the best option moving forward. And the really important message here is that this is something we can do today. You can see here that this would mean building 280 Brock Commons buildings that we have here on BC, that's on the UBC campus, which is one of the tallest wood buildings in the world. This is the opportunity right in front of us, and we have a very large substitution effect and improving our climate change targets. And at the same time, in this scenario, we looked at renewable transportation fuels, but we could also look at bioheat, bioeconomy, other bioeconomy opportunities that this might look again very different. We went with the Clean BC plan, targets, and that's why we looked in this particular case at transportation fuel. But the opportunity here that I can't stress enough is the built environment, building in our communities, using wood in more buildings. And I think we have very great initiatives here. Wood first. Our current government is really stressing mass timber production. We're seeing first plants being built in communities across BC. And I think this is the opportunity that really benefits our communities and addresses climate change. And this 2 minutes is not enough to talk about this, but if you're interested to learn more about this study, please get in touch, and I'm happy to share that with you. Thank you.
Hey, thank you, Dominic. Right. Thank you, Dominic, for that really great perspective on the link between community bioenergy, more advanced bioeconomy, and forest management, and the opportunities for carbon storage with that improved storage, carbon management, or forest management, sorry, and the built environment. So next up, we'll hear from Sevna Madrali with CanMed Energy on the status of community bioenergy projects across Canada.
Good morning, everybody. I'm going to take this discussion from what Dominic has left and give us a potential of what the communities could do with a variety of possibilities that could be coming from sustainable biomass. But I will be focusing more on what's happening on the ground in Canada as it relates to bioheat applications in the communities, and also get into some details and giving you a flavor of the type of work that we are doing at CanMed Energy as it relates to community and the in support of adoption of bioenergy technologies in communities. So CanMed Energy is part of Natural Resources Canada. We have 3 energy labs across the country, and I'm part of the location in Ottawa. We are about 230 staff, and our focus is mainly on the low carbon economy and the technologies and adoption of these technologies in Canada. In terms of low carbon economy, and when we do talk about this in that context, I think what is important for us to keep in mind, and Dominic has alluded to this, the sustainability aspect of the biomass resource that are coming in. To keep that in mind, that would be allowing for, in fact, many nations and regions and cities and communities are considering biomass as part of their climate objectives, but also to become more resilient and competitive. In fact, if I take you over to some of the most recent studies that have been done and published by International Energy Agency, this is in 2019 report, what they have identified and stated that modern bioenergy accounts for half of global renewable energy consumption. This is 5 times higher than the wind and solar PV combined. And if you're looking at the graph on the right-hand side, what you will be seeing that the heat component, the heat sector, in the context of the modern bioenergy is in fact the largest contributor. Now, Canada has been doing at the federal level, as well as provincial and territorial levels, quite many things in terms of their policies and programs. I just here listed a couple of important ones that I think you will be aware of or heard of before. Don't want to spend any time to that, only to point out the fact that the policies and programs in place, there are quite many of them exist, and there are quite many of them also focus on the community aspects. Now, we as a bioenergy program at CanMed Energy aligns ourselves with the directions, the policy directions of the federal government, naturally. And our aim is to advance these national interests through the innovation on the conversion of biomass resources for the production of heat, power, as well as fuels. That could be in the form of solid, liquid, or gaseous. Now, I want to take a higher view and give you a quick overview of how things are in Canada as it relates to bioheat and combined heat and power installations across Canada. This is something that we have been doing since 2013 with the help of Torchlight and Gene. And so we have now about 7 years of data. We are focusing on the commercial and institutional sector, particularly. We are looking at the size range from 50 kilowatt all the way to 5 megawatt scale. And our last data survey we completed in March 2020, and we have plans to do that in the near future again. But our latest data suggests that there is just over 460 bioheat installations in the country. If we were to look at how these installations are being distributed, this is a snapshot of that by the economic development regions. And what you are seeing here is certain jurisdictions have the pretty good and high densities of these installations already. Quebec is the highest number across when we compare to the other provinces and the territories, followed by BC and Northwest Territories. We're also start seeing quite a lot of activities in the Prince Edward Island as well as New Brunswick region. I think what is worthwhile to mention here, the absence of bioheat projects in Nunavut and Saskatchewan. The other thing that it's worthwhile to highlight is majority of the installations that we are seeing in and we are capturing in this database suggests that most of these installations, close to 75% of them, they're under 1 megawatt thermal capacity. And almost all of them are based on technologies that are coming from Europe. We're taking this large data set and we specifically focus on what kind of trends and data that we are seeing on the community-owned projects. And as you are seeing here, there are 75 community-owned projects and those are located in 66 communities. And what is interesting to highlight here is the fact that, in fact, majority of them are located in rural and remote communities. In fact, majority of these rural and remote communities the installations are, in fact, in Indigenous communities. If you were to look at the choice of fuels that are being used by these communities, the data suggests that almost it's 50-50 between wood pellets and the chips, wood chips. And that's really coming from where they are located, what kind of scale of installations that they have. And that's basically seems to be a determining factor for which fuel to choose. This graph is showing you how the trend has been over the years. As I said, we started collecting this data 2013. So anything before that is the confidence I don't have as much as it's not our data, but it's also this graph clearly shows that anything prior to 2010, we didn't have much of an installations and interest to the bioheat installations, and that has started changing in the recent 10 years or so, as also Dominic was referring to. And this increase has been small, but very steady state. One other thing that I would like to mention before I wrap this bioheat section of my talk is the importance of favorable policy regulations as well as funding programs, whether at the provincial territorial level or at the municipal or federal level. The right policy environment with the funding programs seems to have a big impact on the development of these projects. But the other thing that I would like to highlight, I think we are still at the very early stages of the developments for bioheat and community energy systems in Canada. And we have a huge untapped potential that we could all benefit from. I'm going to give you a quick shot of some of our activities happening right now at CanMed Energy in support of the community bioenergy systems. One particular one that I would like to mention is related to de-risking adoption of combined heat and power technologies for the North. And any projects, regardless whether it's North or South, I think needs to have three components in it. And that's the fuel qualities, the supply chains, the technology aspect of it, but also the importance of the capacity building for all of us. We at CanMed, we are a technology lab. Our focus is always on the technology side of the things. And as part of this project, we have, in fact, tested a Volters, a finished combined heat and power technology recently in our labs, and look at its long-term performance of that unit, very similar to what's being tested with FP Innovation and NRC. And we also have a residential scale combined heat and system that we are looking into potential of its usage for the northern communities. I think one other thing is also worthwhile, the importance of the fuel qualities, especially at the scales that we're talking at the communities. The fuel quality makes a huge importance to making sure that the reliable, long-term, successful operations of these systems will be quite much depending on those qualities coming in. Now, the other aspects on the capacity building that I put it on the center, I intentionally put it in the center. I think it's very important for us to consider this. And I personally see there are two components of that capacity building. Not only skilled, trained people that are to be trained for the local operations, but also increasing the awareness and confidence of the potential bioenergy projects could have and could achieve for the program and the funding program people at the government level. I think at the investment level, at the regulatory level, I think there are quite a lot of work we as a community, we should be also focusing on and helping increasing that awareness. Now, any people who have done some projects on the combustion might have heard some of the negative comments coming in for the biomass combustion. It is possible, depending on the systems that you have, depending on the fuels that you're using, harmful emissions could be generated from these systems. But the systems that we are seeing in the recent years that are being installed, as I said, these are pretty advanced modern technologies using pretty well-specified fuels in their applications. And when we look at that, their environmental performance and what kind of data that we might be seeing from those systems, we don't necessarily have a good understanding and sense of where things are. So we started on a project a year ago, and we did a pretty extensive testing of 3 actual installations across Canada. And we are right now in the process of evaluating that data and also trying to see augmenting our understanding with the existing emission reports that other communities and installations have done, so that we could develop a better understanding what those air emissions coming from these advanced combustion systems that are being used by the communities. I'm going to leave you, I have talked about the importance of the fuel qualities, and this cannot be underlined enough in my view, especially for the small scale systems. So we have been, as an organization, putting quite a lot of effort on development of those standards for the solid biofuels that are being used, but also the dissemination of these standards to a wider audiences. So we're working with International Standard Organization as well as Canadian Standard Association Group. And Canada has adopted solid biofuel standards back in 2015. And those standard documents could be pretty technical. So we at NRCan developed a series of technical bulletins, digesting that information into a more easier format, but we're also taking that information and putting into a guidance document for people that are using these standards, producers or the end users, so that they have a better handling and understanding of the best practices that they could be following. And one example of this is a recent guide document that we prepared and published under the CSA group on the wood chips fuel. Now, as my closing remarks, I would like to leave you with this, and that is the communities across Canada and around the globe are already playing a critical role when it comes to the bioeconomy of today. And I think they have even a greater role to play for the bioeconomy of tomorrow. I think one thing the communities can see and should be seeing themselves are evolving to not seeing themselves as part of the forest, dependent to the forest sector, but in fact to be part of that forest sector, working with its forest sector partners. And for their energy purposes and for their energy needs, they don't need to be dependent to the provincial or territorial utilities, but they could be the one who is becoming the utilities for their heat or electricity generation. And that potential in Canada for the communities is big. I'll leave that with those, and thank you very much for listening.
Thank you, Sebna. So it's clear that communities really are already playing a leading role in the bioeconomy. So we'll hear from Jamie Stephen from Torchlight Bioresources next, and he'll give his perspective on what is possible in the future bioeconomy.
Well, thank you very much, Jean, and apologies I can't be on video today. I'm isolating in Nova Scotia, and unfortunately internet technician can't come into our building until we're done this. So we'll just have to make do. I'm Jamie Stephen, Managing Director of Torchlight Bioresources. We've been working since 2008 with communities, with governments and First Nations and companies to assess and to analyze bioenergy, bioproduct opportunities across the country. And we have shifted a little bit of our efforts over the previous couple of years towards more bioheat development. So I will be talking today about municipal bioheat utilities. And the title says it's a proven approach for reducing energy poverty, which essentially means lowering energy costs, improving community resilience, and meeting climate goals. So next slide, please. So first, let's address the proven approach. So Shabnam already showed the global contribution of modern bioenergy to our renewable energy mix. Just an example, in the EU, we see bioenergy and specifically solid biomass contributing 84% of the renewable heating market, which is actually the largest renewable energy market out there. In fact, the amount of energy supplied by solid biomass heating, which is largely wood, is equal to all renewable electricity generation combined, and that includes large hydropower. Slide 3, please. This slide is essentially an extension of the previous one, but shows that in the EU, which is obviously leading climate mitigation efforts, bioenergy represents fully 60% of all renewable energy and was responsible for over 200 million tons CO2 equivalent on an annual basis. So dramatically more than any other renewable. Slide 4, please. So why bioheat utilities? Well, number one, I believe that this is where municipalities can not only contribute, but are absolutely essential to both climate mitigation goals, but also when it comes to community resilience and ability to provide affordable clean energy for their citizens. So number one, it enables use of local wood fuels. Really, particularly when we talk solid biomass, it's about utilizing what is available locally, and therefore is creating the largest number of local jobs per unit energy. As I already mentioned, as proven approach, bioenergy as a whole has a 90% share of the renewable heating market, and that includes things like biogas and renewable natural gas as well. In many cases, despite it creating the most number of jobs, it's also the lowest cost renewable form of heat. And when we talk about how to actually use wood and wood fuels for GHG reductions, heating in particular is the most efficient use of that wood when you're looking at it from a GHG reduction perspective, even if it's replacing natural gas. And that is because of the high efficiency of modern heating and combined heat and power systems. Because you're utilizing a local fuel, the fuel pricing and hence energy pricing can be very predictable. 10 to 20-year supply agreements are possible in some cases. And as Dominic already addressed, this is actually a critical component of sustainable forests. There's a lot of pushback when it comes to utilizing wood for energy, but in reality, we absolutely need a market for low-grade wood fuels, particularly in communities that have lost a pulp mill or a region that has lost a pulp mill. As an example, in Ontario, we've lost 10 of the 15 pulp mills that were operating in 2000. There's huge areas of the province that don't have a market for low-grade wood fiber or pulpwood. And finally, for when it comes to the municipalities on the line, this can be a major source of income, and we see this in Denmark with over 400 district energy systems alone. Slide 5, please. So what does a municipal district district heating utility look like? Well, there's kind of two technical approaches. One is where you actually have pipes on the ground that are carrying hot water. And so this is, what we consider district energy. These can involve off-the-shelf wood chip pellet boilers. When you get to larger scale, combined heat and power plants. And for those communities that already have a pulp mill in their community, there's a lot of waste heat that comes off those pulp mills that is actually another form of bioenergy and can be used for heating buildings. For those communities that are much lower urban density and largely spread out, we can actually have a municipal distributed utility, if you will, without the pipes. And this is individual off-the-shelf boilers. And this is an approach that has already actually been implemented by some rural municipalities in Canada for things like septic systems, whereby the municipality owns and in some cases operates distributed infrastructure at other people's properties. Slide 6, please. So what is district energy? Essentially, it is hot water pipes underground from running heat from a central plant to a variety of buildings. It's only about a meter down, so it's actually in the frost. And so in many cases, that's a much easier utility and infrastructure to operate than water sewer. Slide 7, please. So essentially, there's a central energy plant fueled by, it can be a variety of fuels, and that's one of the wonderful things about district energy is that you're essentially moving hot water. And so anything that can create hot water can supply energy to this type of system. So that's why we call it future-proof infrastructure. It connects buildings to hot water, and within each building, there's essentially a heat exchanger, and that transfers the energy to the internal building heat distribution system, whether that's forced air, hydronic, which is essentially radiators or in-floor heating, or some other type of form of heat transfer. In many cases, these are municipal owned, and we do have some examples, and there's some Ontario ones listed, but there's obviously lots across the country, about 180. Slide 8, please. This provides in a few pictures. On the right, you see the PEX pipe. So this is plastic piping. Below that is thin wall steel. So this is for the larger demands. And then what you see on the left is the in-building heat transfer center. So basically, it's measuring flow and heat differential, and that's how you're able to monitor, and then obviously by extension bill for heat consumed. Slide 9, please. So why does it make sense for municipalities to be in the district energy and also broader bioheat utility business? Well, they're already in the water and sewer pipeline business. District energy is just another 2 water pipelines. And as I've already said, much lower maintenance and much lower difficulty to actually operate than, say, a water and sewer system, because you don't need to, it's a closed system and you don't need to either treat the water or treat the wastewater. However, we spend a lot more money on heating our buildings than we do on water and sewer, and therefore can be a massive increase in terms of utility, not only revenue, but income, depending upon the model the municipality decides to use. Really, I don't believe that municipalities should be in the pilot or demo project business. And that's why really this is all commercial technology. There are thousands of district energy systems in Europe heated with wood. This is really simply replicating what has already been the case, or what has already been developed over many decades. It's future-proof infrastructure. If for at some point in time we come up with some magical way of producing much lower cost energy, this district energy systems are simply just another route to distribute that heat. We all need to heat our buildings regardless of what happens in the world. And unlike natural gas or hydrogen pipelines, this isn't reserved for one type of fuel. It's any type of heat. It allows us to utilize the lowest cost fuels, particularly from the forest sector. We can't be delivering hog fuel to everybody's house. That simply doesn't work, and the emissions would not be particularly good. But when you have a central plant, which requires connection of multiple buildings to increase that energy demand, it allows us to then utilize much lower value and much lower cost fuels like hog fuel, and do so in a clean manner. Finally, jurisdiction. So there's all these municipalities declaring climate emergencies, which is a great thing, but in many cases, they don't have any jurisdiction over the emissions that are being produced. And this is true for transportation. It is true for, in most cases, electricity, and it's certainly true for large industrial emitters. However, heat is very local, and through zoning, municipalities have the ability to actually impact and essentially own municipal heat utilities in Canada. Slide 10, please. So why does this matter? Well, Canada is actually the highest per capita consumer of space and hot water in the world. The only countries that are comparable are the Nordic countries. Slide 11, please. And so when we look at those Nordic countries, which are by far the leaders in Europe in terms of not only the penetration of renewable energy within the energy markets, but also in terms of the lowest GHG reductions, what we see is that district energy is prevalent across all the northern countries except for Canada. You're looking at market penetrations for building heat from 50 to 95% versus in Canada we're at around 1%. And so what the correlation is the more a country has district energy systems, because they tend to use a lot of wood fuels, they have the highest proportion of renewable energy in the market, in total energy consumption, up to 55%, as we see in Sweden as an example. And why this matters is because in Canada, what we see is we obviously have as a nation, a relatively low carbon intensity electricity grid, but electricity is only 17% of our end use energy consumption. So slide 12, just a quick example to wrap up. This is an example from Sweden, which I just mentioned. So Stockholm has a citywide district energy system. It peaks out at about 4,000 megawatts thermal, 350 kilometers of transmission lines, almost 3,000 kilometers of distribution lines. Over 90% of buildings in Stockholm are connected to the system, which is owned by the city of Stockholm in partnership with Fortum, which is a majority owned by the Finnish government, actually. What we can see is that in Sweden, even though they have emissions that are 1/20th per capita of those in Canada, they have a higher GDP. Slide 13, please. So just to show you what is actually possible, this is the Stockholm Värtaverket biomass combined heat and power plant. This is a 400 megawatt thermal plant that heats 190,000 homes using district energy, and it is 100% fueled by wood chips. Consumes about 1 million tons of wood chips per year, so essentially the scale of, say, a pulp mill. This is what is actually required to decarbonize cities in Canada. This one plant generates as much heat, or twice as much heat as the largest district energy system we have in Canada, which is downtown Toronto, owned by Endwave. Chips are delivered 80% by marine, 40% by rail, and this one plant reduces emissions by 650,000 tons per year. And just a few picture slides. Next slide, please. This shows where the plant is. Next slide, please. This shows where the stack is right beside residential neighborhoods. Next slide, please. This is where, this is some of the infrastructure they put in place to have a dedicated dock and rail system. Next slide, please. This shows the chips being unloaded by rail, underground conveyors, and underground bunker storage. Next slide, please. And this shows also the opportunity in rural areas. We have talked already about utilizing forest management, bioenergy and specifically bioheat as complementary to high value solid wood products and providing those rural jobs so that we can grow more sustainable and forests with essentially larger trees. So thank you very much.
Thank you, Jamie, for some really good information for municipalities on the role that they can play in developing bioenergy or bioheating systems in their communities. We've gone a little bit over time with the presentations, so we don't have a ton of time here for questions. We definitely won't get to all of the questions in the Q&A box. And I believe we're going to try and follow up with written responses for the participants after the session. But we will hit on a couple of them. The top question here, and I'm just going to answer this one quickly because I know the answer and in the sake of time. Why were there so many more community-owned projects in 2014 in Sebnum's presentation? 8 of, I believe it was 12 projects in 2014 were in Quebec, and that was the first year for the Residual Forest Biomass program, which provided funding for community and other commercial institutional bioheat projects. And I think in general, the right policy environment for bioheat is really, and especially from a community perspective, is the availability of funding to help with the capital costs because they are pretty high. So moving on to a couple of the other questions here. Let's go to this one. From Jeff Passmore. As a big fan of biomass, he says he believes it's not helpful to appear to belittle the contributions of solar and wind. We're not trying to displace solar and wind, we're trying to displace fossil fuels. We need all renewables to meet the Paris goals. So could the panelists comment maybe on the complementary role that biomass can play and bioenergy can play to supporting the deployment of those other renewables?
Maybe I'll start and the others could come in. I don't necessarily think that we are promoting one over another. And in fact, as you suggested, Jeff, if anything, we need to be looking at this as a complementary to each other. One thing to remember, depending on the locations where you are, wind and solar, especially if it is from the electricity perspective and for the heating applications, there is a complementary role that modern bioenergy could play a role in this. And I think, at least from a community perspective, from heat and powered perspective, they are not competing, but they are complementing to each other. And we are seeing more and more of the projects, in fact, also being considered for how to integrate those different options together for energy generation.
I can comment on the opportunity of certainly to combine the two, and we're seeing that definitely in Denmark, where you have such a high penetration of wind in the electrical grid. Electricity is still a very, quite a minor component of overall energy demand, and I think that's the thing we often forget in Canada. But when you have a district energy system, as an example, it allows you to essentially overload on the intermittent side and have electric boilers, heat pumps, etc., connected to district energy, so that when you have that low cost electricity in abundance, you can heat that district energy system. But fundamentally, you also need a deployable fuel for those times when it's not sunny and when it's not windy. And that's where a critical role as a deployable fuel where biomass can play.
Thank you, Jamie and Sebnem. And agreed that biomass and bioenergy certainly plays a complementary role in the deployment of all renewables, and is particularly useful for displacing some of our heat-related emissions. Along that line, we've got a couple of questions here that might be able to sort of go together. One from David Bonner, pointing out that we and a lot of communities do already have natural gas lines in their community. How would that work, and how do costs compare with bioheat and natural gas? And let's also address the question of what some of the major challenges for municipalities in building out district heating systems might be.
Jamie, do you want to go first on this? Then I will follow up.
Sure, absolutely. So we have done a lot of work on renewable natural gas, and I think there's a role for it. But if you look at the volumes that are going to be available, they're essentially talking 3%, 4% of our current natural gas consumption. There's certainly examples from Europe now, whether it's the Netherlands or Denmark, and I actually posted something on LinkedIn today about this, whereby there is a shift going on from natural gas to district energy systems because this is future-proof infrastructure, because you can use multiple energy sources. And so our $2 a gigajoule natural gas, it's very few energy sources can compete with that. And so the question becomes one of, if we are not going to use natural gas, if we actually want to reduce greenhouse gas emissions and utilize more local fuels, what is the lowest cost renewable option, lowest cost low carbon option? And in most cases, that is biomass. Absolutely, that is a hurdle. The low cost of natural gas in North America is a hurdle to deployment of bioenergy and district energy systems. But we have to decide whether we actually want to enact change or not.
I agree. And I think if I were to take that question from the perspective of what we have seen on the Bioheat survey data, is majority of the installations that we are seeing is benefiting because they are not on the natural gas line, and that bioheat options is really making, with the pellets or chips, is making an economical sense for them. And that funding program coming in really takes that capital investment intensity off of the communities, and then they could move into this option.
Thank you, Sebnem and Jamie. In the interest of time, because we are at 2 minutes after 12 here, I think we need to move on to our next panel. Maybe each of you can just leave us with one quick closing remark on, if you were an elected official or staff member in a local government, what is the first thing you might do, or the one thing you might do to pursue an options in the bioeconomy? Jamie, maybe you first.
Yeah, sure. I can go. So I would absolutely consider, from a perspective, not only a microeconomic perspective, delivered energy costs, but the impact for a community from a macroeconomic perspective of being able to utilize local fuels, particularly in the age of COVID, and how that also impacts resilience and knock-on benefits for your community and the ability to generate income for your municipality.
Great. Thank you, Jamie. Anything to add, Dominic?
Yeah, I think really let's focus on the low-hanging fruits, and I think this is in communities that are not necessarily on the natural gas grid, but that have local forest resources around them. And I think collectively we can do a better job at getting better at utilizing these resources in creating jobs in good local jobs, and replacing fossil fuels in the process. I think that's really the opportunity moving forward. And I think we have proven that we can do it. So now it's a matter of just doing it moving forward. There's lots of resources and success stories, I think, across the board. No doubt about it. There's some hurdles that we need to overcome. But I think it's also addressing some of the other questions that were asked. There is carbon offset opportunities. This is, I think we can't stress this enough. This is local. This is supporting agroforest solutions moving forward. And I think it's a win-win-win from so many different perspectives. Talk, as I said, wildfire, forest management, and community sustainability moving forward. So thank you.
Absolutely. Thank you, Dominic. And Sebnem, I'm sorry, I think we're going to skip you just in the interest of time, but I'm sure you agree with what the others have said, and we can continue the discussion perhaps online or in another venue. David, let's hear from some communities who have experience in implementing some of these projects.